productivity is bad.
Hey Ben.
Hey Matt.
Again, we're going to have to come up with a better intro. But it's cliched now. Like we're actually a caricature of ourselves doing our own intro.
Not do it. If we don't do it, then we're doing a bit. Whereas if we do it, then we're just introducing the show.
I suppose so.
Right.
I suppose so. Since I've started doing like little cold intros as well, I've then lost the bit where we introduce each other and that kind of stuff. So, maybe if we do mix it up a bit. Anyway, hello, friend. What are we talking about today?
Well, I think we're talking about remote work.
Well, which is apt because on Fridays, that's exactly what we both do, which actually enables this very podcast.
Uh-huh. Although I did just have a tangent idea.
Oh.
Maybe we should, I don't know.
All right, no, let's do it. Right, tell me your tangent idea. Come on, everyone.
This is
how planned these are.
This is like a 5-minute pre-tangent to the remote work episode.
Go on then.
How about that?
Do it. I believe software engineer estimates time. Shocker.
Yeah, oh boy. Right. 2 hours later, we're still talking about this. I thought it could actually, this like just popped into my head just as I was, we were starting up the show here, is we could do a like 10 minutes on.
Now it's 10 minutes
on
already.
On 5 minutes on twos complement the data storage mechanism, not the podcast. Like,
you mean twos complement how we store numbers?
Yeah, right. Yeah, well, it's like when you're storing numbers in binary, like you can use twos complement storage to do that. And why would one do that? Right?
Well, why would one do anything but twos complement is
right.
More to the point.
Yes. So I think if you like sit down and you like sort of teach like a sixth grader binary, right? It becomes fairly easy to understand, and you're just using, normal integer counting numbers. And you're like, all right, well, this is the ones place, this is the twos place, this is the fours place, and you add all these things up, right? And then you're like, okay, so computers can only store so many bits. Maybe you've heard of an 8-bit computer, maybe you've heard of a 16-bit computer. They can only perform operations on so many bits, right? So you can see how it'd be pretty easy to just store regular old integer numbers in this thing and have the computer operate on them. And then you might ask that sixth grader, well, okay, but what about negative numbers? And the first thing that they're probably going to say is, well, I guess you could use one of the bits, to indicate whether the number is negative or not. And you're like, okay, cool. Yeah, that works.
It's a fairly obvious thing. It's how we do it in decimal, after all. We either draw a little minus in front or we don't. And that's kind of our one bit of sign. Yeah, it makes perfect sense. We're done here. End of 5 minute.
End of 5 minute thing. And then you say, okay, well, what happens? So that's true. And you can do that. But what happens when the like sign portion of the bits is negative, but the value portion of the bits is 0? What does that mean?
Right. That's like, and again, in decimal, that's like writing -0.
Right.
Like the -0. And you're like, well, I guess that's, I wouldn't write that down. Would you write that down? I wouldn't. So let's just not write it down, right? Let's just not write it down. Let's just all agree that setting the sign bit to 1 and having all of the other bits to 0 is just a dumb thing. Don't do that.
It's just a dumb thing. But then you could see like, but okay, the computers don't like it when we waste things. They don't like that. They want to try to use everything.
1/256th of all the possible representable numbers in an 8-bit thing is just a don't use me. I mean, it could be what about nan or null or empty? We could use it.
You could use it for something like that. But another
I'm going to continue to devil's advocate this for what it's worth.
Yes. It's like we can do it and it will work, but there is a better way, and that better way is called twos complement.
No, okay, yeah.
And in that world, we use that to just represent a completely different number. I actually don't remember which side of the negative chain that is. Do you remember what it is? I'm
Well,
gonna Google it now so I can
negate and
feel
add
it.
one is the kind of like the way that I internalize it. But it closes the gap between 0 and -1 in terms of the number of the bit pattern representation.
Mhm.
Which to me is the other thing that makes two's complement numbers really elegant. It is that most of the circuitry dealing with numbers doesn't need to know if it's signed or unsigned because it just works. It
Yeah.
works the same way. Whereas if you treat the sign bit separately, you now actually have to encode the rules about some of the things that can happen with negative and positive numbers. So it is a really clever trick, and you'll be hard pushed to find a computer that doesn't use two's complement to represent its numbers. But until very, very recently, the C and C++ standards required that, or not required, the C and C++ had made no assumptions about the representation of numbers, and so certain things were defined, but not defined, were left as undefined behavior. You know, you couldn't rely on, for example, adding one to the highest
Mm.
possible number to get it to wrap around to negative whatever,
Okay, yeah,
because
right.
and you know that's usually a good thing because like nobody really wants that to happen, right? If you add let's talk in fact about the two's complementary aspect of this here is like, you know, we have this strange now lopsided number where the highest number we can represent with say 8 bits two's
Mhm.
complement is 127, but the
Yeah.
lowest is minus 128, which is kind of displeasingly
Right,
asymmetric.
right.
And that
Uh-huh.
also means that you can't just unary negate any number and get another number because it's if I have minus 128 and I get the negative of it, like, oh, whoops, can't represent
Yeah.
128 anymore. So there are
Yeah,
some
yeah.
weird edge cases as well. We've kind of pushed them around rather than at the 0 point. They're now at the extents. And so
Mhm.
it's kind of reasonable that if you added one to 127, and you suddenly got minus 128, you probably didn't really mean to do that. You didn't want that to happen. And so it's left as undefined behavior. And so compilers can usually optimize around that and say, look, you're not, we weren't expecting you to do this, therefore I'm not required to do it this way. For example, um, it may be that you use a bigger representation than an 8-bit value when you're using a signed 8-bit value, and that means that the
Mm.
carry rules don't work the same way. But it's also not supposed to happen. So the compiler might be able to use a 32-bit register instead of an 8-bit, like shift and add and shift and add all the time, things like this. But very recently, they gave up on pretending that computers aren't two's complement, and they actually accept that like all practical computers these days are in fact two's complement. And I forget exactly the ramifications of this. Those who know me well know that I don't really participate much in the C++ standardy type stuff, but that one just came up on my radar. So I apologize for not having the, especially when you just dropped this on us at the beginning of this podcast. I haven't researched it in any meaningful way. And I have a very loud mechanical keyboard, so I can't even Google it while we're talking.
Well, I also have a loud mechanical keyboard, and nothing prevents me from doing that other
Oh,
than the
short of me
clackety
having to
clacks that are
edit
yes.
out the clacks in a minute.
The low
No,
pass filter.
what an awesome idea. Yeah, the idea that yeah, we've named our podcast after a very, I think, a neat trick.
It is a neat trick. It's very elegant.
Yeah,
It's and there's just something abhorrent to me as a programmer about having any sort of mechanism that just allows for nonsensical values by its structure, right? Like if I can ever find something where it's like those types of problems just aren't possible, that is always going to be a better solution, and this does that very well. So,
absolutely. Correct by construction is the
yeah.
sort of way that I've always sort of internalized that.
Yeah, yeah, that's
Although
the phrase people use.
I will note that in the original Knuth book, so the Art of Computer Programming, all the various
Mhm.
volumes, the mix architecture. So Knuth is just such a legend for me for two reasons. One, he wrote like the book or the books on
Mhm.
all algorithms, which are like the most um, abstract things, like how to sort numbers, all the hundreds of ways you can sort numbers, very abstractly. But then he wrapped around on the, you know, talking of numbers that that wrap
Right.
around, he wraps around to the exact other side where he then implements them in assembly code in a computer that doesn't exist that he made up so that he can demonstrate the purity of his algorithms using this invented machine, the mix. Nowadays, there's a RISC-based one that has, you know, mmix or something like that. But the one I remember growing up as a kid, oh gosh, reading was the mix one. And the amusing thing about that is, and forgive my readers, listeners, whoever they are, will hopefully forgive me if I get this a bit wrong. It is a sign bit based computer that is decimal. It stores numbers decimally with a
Hmm.
sign bit. So you do in fact have plus and minus zero. And then to your point about waste, Knuth goes as far as micro optimizing his own made up instruction set for a computer that doesn't exist to implement algorithms that are like all about the big O notation and not about the constant factors. But he optimizes them anyway because he's Knuth. And he starts using the sign bit to essentially encode a Boolean flag, because obviously these numbers, these values in here can also be pointers, and it
Hmm.
doesn't make sense to have a negative pointer. So he
Hmm.
just uses like the decimal part as the pointer address. And then you can also, for free, get this 1-bit flag. And so some of his algorithms will like stuff things in that one extra bit. So it's not wasted in those instances. You know, a null pointer with the bit clear is different from a null pointer with the bit set, because it might mean null but red or null but black in a red black
Oh
tree,
wow.
things like that. And just now, you've lit the litmus paper under me, and I'm going now. Um, a good friend of mine has just put together a proposal for the C++ committee about canonifying reserving certain bits in pointers. Many things, you have a pointer, it points to an address in memory. The things you point to have to be aligned at certain spaces. So, if you have a double precision number, that's an 8-byte quantity. On almost any hardware, you have to have it at an 8-byte address. What that means is every pointer has wasted bits at the bottom, which always have to be 0 because it has to be a multiple of 8, right?
Hmm.
So if you can just mask those 2 bits out, you can access it as a pointer. But if you mask them in, then you've got some bits at the bottom. You've got 2 or 3 bits worth of like extra information.
Hmm.
And
Hmm.
so she's put together a proposal which says, like, can we canonify this? Because strictly by the book, you're not allowed to do those kinds of things. Because once you start manipulating a pointer like it's an integer, the compiler
Mm.
can lose track internally that it points to a valid particular object and whatever. But she's made it so that that's okay. Um, so yeah, sometimes if you do have redundant representation that's wasted bits, you can find another use for them.
Well, someone will find a use for
Someone
them
will find you. Whether
because
that's
that's
good
how
or
that
bad, I
works.
don't know. But
Yes,
no, Hannah uses it in a really smart way. In fact, we had her on the podcast. Ah,
we did.
yes. So Hannah Duskova is behind that proposal, and very smart it is too. And it's definitely something I'll be looking to use myself. And, sneaking bits in. Anyway, that was not 5 minutes,
No, it was not
but
five
we can talk
minutes.
about remote work now.
Now we can talk about remote work.
So new needle scratch.
Yep.
Tell me about how remote works for you.
Well, okay. I think the main thing for me is remote work is a trade-off between collaboration and productivity, essentially. I
Yes.
currently am working with people who are either in California or New York, despite the fact that we have a Chicago office, and that is
Mhm.
just
And
pure
that's where you are.
happenstance. That is, yes, I am a
If you
Chicagoan.
can't pick it up from the
We are
accent.
Chicago Ans. Chicago. What's the multi? I don't. Anyway, um, so I am I commute into our Chicago office a few days a week, mostly to see my friends. That's the main reason that I do it, because the people that I work with are actually in California and New York, and
Right.
I'm going to be talking to them over some sort of Slack or video call or
Mhm.
something like that, no matter where I am. So regardless of where I am actually physically, it's the same medium. Um, but there is a lot to be said, and I know that people have made this complaint before, and this was obviously true for a lot of folks in COVID, but it's even still true for folks that sort of choose to have a fully remote. They either work for companies that are fully remote or
Mhm.
they have roles that are fully remote. Um, some amount of face-to-face interaction is, I think, for most of the people that I've talked about this with, some amount of face-to-face interaction is really important, because like it's hard to develop those relationships when you are talking to everyone over a video chat. And you can do it, and lots of people do it, but it's harder. Is a refrain that I've heard a few times.
It was interesting. I was discussing with a friend the other day about um, how you can keep in touch with friends from like home. I've moved away 4,000 miles away from most of my friends when I was growing up,
Hmm.
and a way that you can keep in touch with friends is playing video games where you can actually now talk to people in real time. And I was
Hmm.
regaling them in the pub the other day with the stories in like the late 90s where for whatever reason I wasn't leaving the house very much and there's all sorts of things going on in my life, but I was playing EverQuest and I have now made, real life friends over what was
Hmm.
purely a text based thing. And to this day, I still talk to them. And yes, you can build a relationship using text medium, using face to face medium like this, but it's harder. And it
Hmm.
only really happens well under like, I think under either duress or a really concentrated on both sides thing where you both work at it to build that thing because unfortunately evolution is kind of against us, right? We have picked up
Yeah.
on so many subtle cues about how humans interact, how and for those folks obviously I'm talking about sort of very neurotypical things here, but like everyone
Mhm.
there are different degrees of this that you can pick up on, but like to a first approximation, just being in a room with someone tells you a lot about how they are, and you can learn about them so much more naturally. I don't know what the right word, I'm searching for the right
Yeah.
words here, but yeah, so
It's just a higher bandwidth interaction.
I suppose that's it. Yeah.
I
And
think the other thing about it is that when you're remote, there are very few accidental interactions,
yes,
right? You
everything
know?
has to be really intentional, doesn't it? You have to like schedule a coffee chat or whatever, rather than like bump
Yeah.
into someone as you're passing in the hallway to the
Hmm.
bathroom, even right. Even at that level.
Yeah. How many times have you had like an all company meeting and you get there a couple minutes early and you just sit down next to a random person and you start talking to them,
Yeah.
right? And maybe you know them a little bit, maybe you know them well, but like that kind of interaction doesn't happen when everyone joins the all company Google Meet. Like you're not chatting in the meet in front of everybody else, right? Like that's not going to work. So like, those sorts of accidental things I think can play a big part. But like the actual act of programming, like writing code, I am increasingly, and I think COVID was really the thing that tipped the scales for me here because I was forced to create such a productive home setup
Yeah.
that is so well optimized that I like. There's no question to me that I'm a more productive programmer when I'm staying at home, even if you were to take out the commute time, which isn't really a fair thing anyway. But even
No.
if you were, I think I'm more productive.
I definitely agree with that, although I don't agree
Mhm.
with the having built myself a productive environment. Because if you could see the camera right now, or like
Yeah.
down from here, it is a catastrophe where I am. But I meant to do that, to fix that today, and I did not. Yeah, the main person in my life who pointed out how important it is to go into an office is in fact my wife, who obviously during COVID was forced to
Hmm.
suffer the full time with the husband that she was, very. We have a great relationship, but I think all of us suffered from being in the pockets of each other for a while. But she's like, you need it. You need to go and see other people, and she
Hmm.
was right. And I like to pride myself on being, rational, logical, not really whims driven by the sort of more animalistic whims of our reptilian brain. But she's right.
Yeah.
I absolutely needed it. And yeah, I agree. But in terms of focus time, obviously we kind of build our own focus time in the office with headphones.
Hmm.
We or by trying to find a sort of space away from the general thoroughfares to kind of get some stuff done. But yeah, you kind of that's the default situation at home. Um, Dog
Yeah.
barking notwithstanding, kind of levels of things. And yeah, and the very lack of those interactions at home, the lack of the non intentional interactions is actually the source of focus. Like I can get up and I can make a cup of tea, and I'm still thinking about the problem that I'm working
Hmm.
on while I'm waiting for the kettle to boil. Whereas probably more healthily in open in an office, I'm talking to somebody who's also waiting for whatever, for the coffee machine or whatever. And maybe that break is actually what I do need, but focus
Yeah.
wise, it's true.
Yeah, you definitely don't have the rubber ducking effect when you're at home, where you're working on some hard problem and you stand up in a equal mix of frustration and need for coffee, or some other thing. It's like, well, I guess now's the time I need to go and get a snack or whatever.
Yeah.
And then you run into somebody who will at least understand your problem,
Right.
and you wind up explaining it to them.
Right.
Yeah.
And then you
Uh,
solve it because you're like,
right.
"Oh, wait," or they
Yes.
just make some astute observation that's, like, to them,
Mhm.
blindingly obvious, but to you has been stopping you from getting progress for, like, the last, "Oh, I don't know you
Right.
could do that." Oh, of course,
Yep.
that's the solution, yeah.
Yep. Yep.
Yeah, and that's hard to recapture, as you say, remotely. I mean, if you've
Mhm.
got, as you well know, I'm very well versed at just puking out my thought process into Slack into a long thread of things, and hope that sometimes brings people along for the ride in terms of what I'm thinking, or gives them
Mhm.
people come in and say, "Why are you doing that? That's stupid."
Mhm.
But again, it requires intentionality. Um,
Yeah. And so the plot twist of this whole thing, I think,
oh,
is that you can make the argument, and I enjoy remote work in it, and I do feel very productive when I do it, and I do it because I'm productive. But you can make the argument that productivity, in its very purest sense for programmers, is bad.
oh,
And the
this is
reason I say that is because I have had many times in my life, and I think that this is more common when I'm remote, when I'm working by myself, when I got my headphones on or whatever, and I'm just in the zone and I'm programming, where you are creating code. And as we've talked about before, code is a liability.
mm,
Code is not good. We're trying to
I
solve problems,
I
not make a bunch of code that we need to maintain and test and deploy and debug and all the other things. And there are many times when the right thing to do is not just puke out a bunch of code as efficiently and productively as you can, but to take a step back and to maybe talk to a few coworkers and be like, do I even need to be solving this problem at all?
That, my friend, is absolutely spot on. I mean, yeah, so in the throes of COVID, there is at least one reasonably large chunky piece of code that I'm very proud of and is used, but ultimately is now being phased out because really was overcomplicated, could be replaced with something a bit more straightforward. Was part of a grander vision that didn't come to being, and now ultimately, it ultimately, yeah, should not have never been written, and it
Mm-hmm.
served a purpose. It kept me amused for a few months while I was sat rocking slowly backwards and forwards in this very chair. But no, that's a really interesting observation. That unfortunately though, as programmers, we love that state and we love
We
doing that
do.
and we love that thing, as
Yes.
we've discussed before, the whole
Right.
flow and all that good
Mm-hmm.
stuff. So
Mm-hmm.
it is hard to it's hard to give that up and
Yeah.
say, no, I should go and talk to someone who will talk me out of writing this wonderful lock-free doodad or this whatever,
Right.
thing, because they say like, well, why don't we just write a file
Right.
to disk?
Yes. Do you really need this fancy thing? And I mean, a lot of the time that is a very productive and good state to be in, but it
Yeah,
is not strictly true that it is always good,
yeah,
at the exclusion of interacting with other people, double checking your ideas, making sure that you're doing things that actually need to be done, and making sure that you're doing them in a reasonable way and not just like going all full mad scientist and being like,
right. Or you 10x developer, and then you've got
yeah,
10x as much code that no one else understands or has seen and doesn't
right.
even need. And you're like, as you say,
Yes.
it's a liability. No, that's a really interesting observation.
Yeah. Yeah.
Well, that seems like what a two-tone kind of
We could
podcast we've
split
recorded
this in
today.
half and do it in two parts if it
I
wasn't
don't
like
know
30
that
minutes long.
I'm not skilled enough an editor for that, so I'm afraid everyone's just going to end up with it pretty
Yeah.
much raw.
This
Uh,
is going to be the peanut butter and pickle sandwich of Two's
hmm,
Compliment podcasts.
that doesn't sound too bad.
It's
So,
disgusting. I don't know why anyone would eat that, but we're just going to
what?
take two things. Actually, you know what this is like? Did you ever see
Yeah,
the
go on.
movie From Dusk Till Dawn?
Oh my gosh, I actually think I've seen that movie.
Yeah.
That's the vampire one, right?
Well, the second half is vampires. The first half is a bank heist movie.
Oh yeah, oh yeah. I just remember it as vampires, but yeah, now you say that, I'm like, oh yeah,
Yeah.
it's like a cut and shut.
Uh-huh. Yeah, it was
Whatever. Does that
I
word? I don't even know if that translates across the pond.
Actually, I'm not sure I do know what that means.
It's where you've had two cars that have been involved in an accident, and they're cut in half, and the good halves are then welded together to make like one good car out of the two. No,
I've
is that
never
not a
heard that.
thing? No, yeah, like you can imagine
Never
like
heard that before.
two Ford Focuses one's been smashed in the front, one's been smashed in the back. So you just cut them in half and stick them together, and you sell it as a good car. Nah, only the
Okay.
British can be so unscrupulous as to do something like that. It surprises me, but whatever. No, so it's like from dusk till dawn. Yeah, the
Yeah.
two-tone thing. Yeah. Okay.
Yeah. The first half of this podcast was a bank heist, and the second half we talked about remote work.
That's
Yeah.
awesome. Well, to that effect, I think we're pretty much done for this episode, and so I will speak to you on the next one.
Yep, next time.
You've been listening to Two's Complement, a programming podcast by Ben Rady and Matt Godbold. Find the show transcript and notes at www.twoscomplement.org. Contact us on Mastodon. We are at twoscomplement@hachyderm.io. Our theme music is by Inverse Phase. Find out more at inversephase.com. Only the British can be so unscrupulous